Hi there, this is Penelope. This is a short video on finding the mean value of a function. It's often included in exam questions where you find the integral first between a couple of limits, then find the area under that curve between the same limits, and then frequently you're asked to, for the last few marks, to find the mean value of a function. The formula is that the mean is equal to 1 over b minus a times the integral between a and b of the function. Now, all of these things are just formula involving integration. You'll be given the right formula in the exam if you need to use it, so you don't need to worry about that. The integration itself isn't any harder, it's just integration. Okay, let's go. In this case, we've got our limits between 0 and CR, and the function is capital Q e to the negative kt. And now I'm going to use that for the average charge. Now what I'm going to do is K is 1 over CR, so K is 1 over CR, you're told that, and CR then is 1 over K. Okay, so we're just flipping those around. Now we've got 1 over CR, so that's K, and I'm going to take the Q out, and then I'm going to integrate between 0 and CR, and all I've got now is the exponential function. That was just a little bit of side algebra there. Okay, so that's going to be, oh, we can also put this back in as well because we've got a K here, so it might help. So let's call CR 1 over K, 0 e to the negative kt between tt. Do the integration. So it will be e to the negative kt over k, and a negative out the front because of the negative power. And now if we bring that k out the front and leave what's in the bracket, then we have, that's going to cancel, so we have Q times, now I'm just going to carefully substitute in the values, so it would be negative e to the negative 1 minus negative e to the 0, and don't assume that the e to the 0 is 1 because it isn't, so that's Q times negative, now e to the negative 1 is 1 over e, plus, because it's minus minus 1, and you could leave it like that, or you could make it approximately 0.632 coulombs. That's to 3 significant figures. So you're given the rule, you just have to remember that if you're trying to find the mean value or the average, that you just look up the formula that you're given. Okay, next question. Find the mean value of the voltage V equals 3 cos omega t plus 2 sine 2 omega t between t equals 0 and t equals pi over 2 omega. Okay, right, so the average then is going to be 1 over pi over 2 omega minus 0 times the integral between 0 and pi over 2 omega of the function and I am going to invert this fraction here, so it's now going to be 2 omega over pi, and I'm going to integrate each bit. So the first one would be 3 sine omega t over omega minus cos 2 omega t over 2 omega. That's got to be between the limits as given. What a mess. Okay, 2 omega over pi, and I'm going to put in for my first term, it's going to be, I better use 2 brackets, so it'll be 3 sine omega times pi over 2 omega over omega minus cos 2 omega times t, which is pi over 2 omega over 2 omega. That's my first, putting in my first limit, and the 2 pi, the 2 omega over pi applies to the whole lot, minus 3 sine 0 over omega minus cos 0 over 2 omega. Give myself some more space. 2 omega over pi times, okay, cancelling all that I can cancel, then, because that's going to go, and I'm going to have 3 sine pi by 2, which is just 1, so it's 3 times 1, minus negative 1 over 2 omega, minus, now I'm going to do the same, it'll be 0 over omega, because sine 0 is 0, minus cos 0 is 1, so it'll be 1 over 2 omega. And now all I've got left is 2 omega over pi times 3 over omega plus 2, eventually, 2 over 2 omega. So we've still got the 2 omega over pi, and in our brackets now, if we use fractional adding fractions, we will get 4 over omega, and cancel the omegas, and then we have 8 over pi. You could leave it like that, or you could approximate to 3 significant figures to 2.55. Don't forget your unit, volts.